Good morning, students. Now we discuss about the exercise 7.9 second problem. Sketch the graph of the function subdivision 1 y equal to minus 1 by 3 x cube minus 3x plus 2. So now sketch the graph means we calculate the domain, intercept, and next gravity, everything we find out. So first I calculate the domain. So this is the function y equal to minus 1 by 3 x cube minus 3x plus 2 is the function. Domain are in the entire interval. So domain in the entire interval is minus infinity comma plus infinity is the domain of this interval, because you see here in this function there is no denominator. Suppose there is a denominator, we just leave that numbers, particular numbers. After that we consider the real numbers. So here no denominator here, so we consider the full real functions, that means minus infinity comma plus infinity. Therefore domain are in the entire interval is minus infinity less than or equal to x less than or equal to infinity. Intercept means x-intercept means y equal to 0. So now you substitute y equal to 0 in the functions. So 0 equal to minus 1 by 3 x cube minus 3x plus 2. So the next step, x cube minus 3x plus 2 equal to 0. So now I factorize this, that means x cube minus 3x plus 2. So now I substitute x equal to 1 in this equations, 1 minus 3 plus 2. So 1 plus 2 3, 3 minus 3 0. So equal to, so we substitute x equal to 1 in this equation, we got the answer 0. Therefore x equal to 1 is a solution. So I write it x equal to 1 as a factor, x minus 1. So x minus 1 is a factor of f of x. Therefore now I write it x cube. Now I take the division method. So I write x cube, that means now I write all the coefficient. So x cube coefficient is 1. Next x square term is 0. So I write it coefficient is 0. X coefficient is minus 3 and the constant is plus 2. Now so x equal to 1 is a solution. So now I divide this coefficient by 1, because x equal to 1 is a solution. So that solution divide this coefficient. Therefore 0. Now in the 1 and here I put it 0. So this number 1 I write it the 1 plus 0 1. So 1 into 1 1. So 0 plus 1 1. Again 1 into, I multiply this 1 into 1 1. I write it here. Now I add, that means within the box we add the numbers. Minus 3 plus 1 is minus 2. So again minus 2 into 1 is minus 2, plus 2 minus 2 is 0. This is the remainder. Okay, so the remainder is 0. Therefore x equal to 1 is a solution. And now we form the equations. Now this is the minus 2 we consider from the last. Minus 2 consider the constant, 1 consider the x term, and next term 1 consider the x square. Therefore the other factor is x square plus x minus 2. Now we write the equation x equal to, that means x already we take the one solution, x equal to 1. So that means x minus 1, first factor x minus 1, next factor x square plus x minus 2. From these numbers we form the factor, that means this is a constant, this is the x, this is the x square. So x square plus x minus 2 equal to 0. The next step, now we factorize this x square plus x minus 2. So we write it, that means the coefficient of x is 1 and the constant is minus 2. So minus 1 into, now we write it, that means we choose two numbers, minus 1 into 2 minus 2. We add these two numbers, we get the answer plus 1. You see now minus 1 into 2 minus 2. We add these two numbers plus 1. Therefore we factorized by x minus 1 into x plus 2 equal to 0. So x minus 1 into x minus 1 into x plus 2 equal to 0. You see x minus 1, x plus 2. That means we factorize x square plus x minus 2. We factorize by minus 1 into 2. So I write it x minus 1 into x plus 2 equal to 0. So we take x minus 1 equal to 0, x plus 2 equal to 0. So x equal to 1 and x equal to minus 2. Already we got the one solutions, x equal to 1. That means here x minus 1 equal to 0 and x minus 1 equal to 0 and x plus 2 equal to 0 means x equal to 1 comma 1 and x equal to minus 2. You see y-intercept. Now we find out the y-intercept. Y-intercept means we calculate the x equal to 0. So we substitute the functions x equal to 0. So x equal to 0 means You see, listen here, y-intercept means x equal to 0, x equal to 0 means you see y equal to minus 1 by 3 into, we substitute, we know that if given functions, in that given functions we substitute x equal to 0, so 0 cube minus 3 into 0 plus 2, so we write it, that means y equal to minus 1 by 3 into 2, so minus 2 by 3, y equal to minus 2 by 3, therefore the point is x equal to 0, we got the answer y equal to minus 2 by 3. Critical points of the function, so critical point of the function is f of x equal to minus 1 by 3 into x cube minus 3x plus 2. Now we differentiate the functions. F dash of x equal to minus 1 by 3 into, we differentiate it. Differentiation of x cube is 3x square minus 3 into differentiation of x is 1, so minus 3. So therefore next f dash of x equal to minus 1 by 3 into 3. Now here 3 is common, so I take from this factor, so I write it 3 into x square minus 1. Therefore f dash of x equal to 3 cancelled, minus into x square minus 1. Therefore f dash of x equal, now I take the critical point. We need the critical point means the condition is f dash of x equal to 0, therefore f dash of x equal to 0 means minus of x square minus 1 equal to 0, so x square minus 1 equal to 0, x square equal to 1, so x equal to plus or minus 1. Hence the critical numbers of the curve is x equal to plus or minus 1, that means x equal to minus 1 and plus 1. I represent minus 1 plus 1 in the interval minus infinity comma plus infinity, so I take already, so minus infinity, minus 1, 0 and plus 1, because and the x value is x equal to 0, x equal to minus 1 and plus 1. So therefore here I mentioned the three numbers in the number line, minus infinity, minus 1, 0, 1, infinity. This is the critical values, critical points, x equal to plus or minus 1. So you see local extreme of the function f dash of x equal to minus 1 by 3x square minus 3, differentiate with respect to x. F double dash of x equal to minus 1 by 3, again I differentiate 3 into differentiation of x square is 6x, so 1 by 3 into, that means 6, 3 into 2x is 6x, differentiation of minus 3 is 0, so minus 1 by 3 into 6x, 3 cancelled, therefore minus 2x. F double dash of x equal to minus 2x. Now we substitute x equal to 1 in the f double dash, so f double dash of 1 equal to, here you substitute minus 2 into plus 1 minus 2, it is a less than 0, minus value represented by less than 0, less than 0 means maximum, so maximum. Next I substitute x equal to minus 1 in the functions, so f double dash of minus 1 equal to minus 2 into minus 1 plus 2, it is greater than 0 minimum, therefore the curve has local minimum at the point x equal to minus 1 and the local maximum at the point x equal to plus 1. So x equal to plus 1 is the local maximum and x equal to minus 1 is the local minimum, therefore I write it, now we find out the minimum value and the local maximum value. So f of x equal to, I write the given functions, f of x equal to minus 1 by 3 x cube minus 3x plus 2. Now I substitute x equal to minus 1, x equal to minus 1 means f of minus 1 equal to minus 1 by 3 into minus 1 whole cube minus 3 into minus 1 plus 2, so therefore minus 1 by 3. Now minus 1 whole cube means minus 1, minus into minus plus 3 and plus 2, which implies f of minus 1 equal to, just we add it, 3 plus 2 5, 5 minus 1 4, so minus 4 by 3. This is the, therefore the local minimum, x equal to minus 1 give the minimum value, so local minimum value is minus 4 by 3. You see the local minimum value is minus 4 by 3, therefore when x equal to 1, f of 1 equal to, we just substitute minus 1 by 3, 1 cube minus 3 into 1 plus 2, that means minus 1 by 3, 1 minus 3 plus 2, that means 3 minus 3 is 0, f of 1 equal to 0, therefore local maximum value is 0. Intervals of concavity, means here I take the x equal to 0, so I represented here. So now intervals of concavity means f double dash of x equal to 0. This is the condition for intervals of concavity. First I find out the f dash of x. So f dash of x is, so f dash of x is minus x square, minus of x square minus 1, this is the f dash of x. So that means we know that given functions y equal to minus 1 by 3 x cube minus 3x plus 2. After that we differentiate the given functions. F dash of x equal to minus 1 by 3 3x square minus 3. So we just cancel the 3, we get the answer minus of x square minus 1. This is the f dash of x. So differentiate with respect to again, second time again differentiate. F double dash of x equal to minus into x square. Differentiation of x square is 2x, so minus 2x. Therefore the condition intervals of concavity, so the condition of concavity is f double dash of x equal to 0. So that means minus 2x equal to 0 means x equal to 0. Therefore so x equal to 0, this is the x values, so I substitute in the number line. So minus infinity, 0, infinity. So therefore the intervals are minus infinity comma 0, 0 comma infinity. Therefore minus infinity comma 0. So minus infinity comma 0 means we substitute any value from this interval. Suppose I take the x equal to minus 1, I substitute in the f double dash. So f double dash of minus 1 equal to, we know that f double dash of x equal to minus 2x. So minus 2 into minus 1 plus 2, so it is a greater than 0, so it is a concave upward. Next is 0 comma infinity. 0 comma infinity means you take x equal to 1. So x equal to 1 means f double dash of 1. F double dash of 1 means you take that means minus 2 into 1 minus 2. So minus 2, it is a less than 0, it is a concave downward. Therefore the point of inflection are at x equal to 0. So the point of inflection is x equal to 0, we substitute in the given function. So you see x equal to 0, I substitute in the given function. The given function is y equal to minus 1 by 3 x cube minus 3x plus 2. So I substitute x equal to 0. So x equal to 0 means minus 1 by 3, 0 minus 3 into 0 plus 2. That means y equal to minus 2 by 3. This is the y point. Therefore the point of inflection is 0 comma minus 2 by 3. Therefore asymptote. The curve does not have asymptote. So this is the diagram curve for the asymptote. So y equal to x into square root of 4 minus x. Now we calculate the domain. So the domain is minus infinity. Here you see domain of the function is well defined in the interval minus infinity comma 4. So that means you take the minus infinity comma 4 or x less than or equal to 4. So here the domain of the interval is minus infinity comma 4 or x less than or equal to 4. So next intercept. Now I can calculate the x-intercept. X-intercept means y equal to 0. So y equal to 0 means now you take the function y equal to x into square root of 4 minus x. You substitute y equal to 0 in this functions. So you see y equal to 0 means the left hand side 0 equal to x into square root of 4 minus x. So you reverse the equation. Here you reverse the equation. That means x into square root of x minus 4 equal to 0. So next step, there is a two factor. One factor is x, another factor is square root of x minus 4. So x equal to 0 and square root of x minus 4 equal to 0. So x equal to 0 and x minus 4 equal to 0 means x equal to 4. Therefore y-intercept we find at the 2.1 is x equal to 0. So x equal to 0 means so the y value is again I substitute x equal to, there is a 2.0 and 4. So first value I take x equal to 0 means I substitute in the y equations. Y equal to x into square root of 4 minus x. So 0 into 0, 4 minus 0. So 4 minus 0 means it is equal to 0. So the point is x equal to 0 and y equal to 0. Next we calculate the critical point. So critical point means we take the condition f dash of x equal to 0. So first I write the f of x, the given functions. F of x equal to x into square root of 4 minus x. This is the given functions. Now I differentiate. So differentiate with respect to x. So f dash of x equal to, there is a two functions ub. So differentiation of ub is ub into dv plus v into du. So therefore x into differentiation of square root of 4 minus x is 1 by 2 into 4 minus x whole power. That means 1 by 2 minus 1. So this is a differentiation of square root of 4 minus x, and the differentiation of 4 minus x is, differentiation of 4 is 0 and minus x is minus 1. So I write it here. So therefore plus, next I write the second term square root of 4 minus x and I differentiate the x. Differentiation of x is 1. Therefore, so I write it. That means 1 by 2, the first term is x into 1 by 2. in the power 4 minus square root, that means 4 minus x whole power minus 1 by 2. Thus that minus 1 by 2 are right in the denominator. So 1 by 2 into square root of 4 minus x into minus 1 plus square root of 4 minus x. You see, f dash of x equal to, that means minus x by 2 into square root of 4 minus x plus 4 minus x. Now f dash of x equal to, is just doing the cross multiplications. So square root of 4 minus x into 2 into square root of 4 minus x, you multiply, cross multiply this. So 2 into square root, it is cancelled. So 4 minus x, 2 into 4 minus x by 2 into square root of 4 minus x. In the next step, now you multiply the 2 in the factor. So 4 to the 8, 2 into minus x minus 2x. So by 2 into square root of 4 minus x, which implies f dash of x equal to, now minus x minus 2x is minus 3x. 8 minus 3x by 2 into square root of 4 minus x. Therefore let f dash of x, now we find out the, so now we find out the critical points. The critical point condition is f dash of x equal to 0. So we found the f dash of x. F dash of x equal to 8 minus 3x by 2 into square root of 4 minus x. Therefore 8 minus 3x by 2 into square root of 4 minus x equal to 0. So just multiply the denominator in the 0, so equal to 0. So 8 minus 3x equal to 0. So the next step, this minus 3x are right in the RHS. So 8 equal to 3x. So x equal to 8 by 3. So this is the value. Hence the critical numbers of the curve is x equal to 8 by 3. This is the value. So local extreme of the function. Local extreme of the function is, now we know that, that means we need the local extreme. So f dash of x equal to 8 minus 3x by 2 into square root of 4 minus x. That means local extreme means we need the f double dash. So again we differentiate the f dash. So we differentiate, second time we differentiate the f dash, means we get the f double dash. So differentiate with respect to x. F double dash of x equal to u by d of u by v. D of u by v is v square, that means v into du minus u into dv. So therefore now we square the denominator. 2 into square root of 4 minus x whole square, 2 into square root of 4 minus x into, now I differentiate the numerator. Differentiation of numerator is 8 minus 3x. So 8 minus 3x means differentiation of 8 is, that means 0, and the differentiation of minus 3x is minus 3, because the differentiation of x is 1. So I write it 0 minus 3 minus, now I write the numerator 8 minus 3x into, now I differentiate the denominator. Denominator function is 2 into square root of 4 minus x. So 2 constant, I write it under differentiation of square root of 4 minus x. Differentiation of square root of 4 minus x is, that means first I differentiate the power. The power is 1 by 2. So I write it 1 by 2 into 4 minus x whole power 1 by 2 minus 1. That means 4 minus x whole power minus 1 by 2. Next I differentiate the base. Base is 4 minus x. So differentiation of base is, that means the differentiation of 4 is 0. Differentiation of minus x is minus 1. 0 minus 1. Therefore 1 by 2 into square root of 4 minus x. In the next step you write it now. So you see f double dash of x equal to 2 into square root of 4 minus x into minus 3 minus 8 minus 3x into minus 1 by square root of 4 minus x. Therefore 2 into minus 3 minus 6 square root of 4 minus x minus into minus plus 8 minus 3x 1 by square root of 4 minus x by 4 into 4 minus x. The next step, now that means you write it minus 6 into square root of 4 minus x plus 8 minus 3x by square root of 4 minus x by, now you multiply the 4 into 4 16 minus 4x. So in the next step you write it, that means you're just doing the cross multiplication. Minus 6 into square root of 4 minus x, square root of 4 minus x is 4 minus x plus 8 minus 3x by square root of 4 minus x by 16 minus 4x. So in the next step you write it, that means you just multiply the minus 6 into factor. So minus 6 into 4 minus 24 minus into minus plus 6x plus 8 into minus 3x by square root of 4 minus x by, that means you take the 1 4 from this. So 4 into 4 minus x. The next step you write it. Now you add the terms. Minus 24 plus 8. Minus 24 plus 8 is that means here minus 16. We add the minus 24 plus 8 minus 16. You add the 6x minus 3x. 6x minus 3x is plus 3x. 3x minus 16 by square root of 4 minus 6 into 4 into 4 minus 6. The next step 3 minus 3x minus 16. That means next this 4 minus 6 we write it the square root of 4 minus 6 square root of 4 minus 6. So you just that means we write it 3x minus 16 by, we write the numerator here 3x minus 16 by square root of 4 minus 6 into, again we write the denominator into 1 by 4 into 4 minus 6. In the next step 3x minus 16 by, that means 4 into 4 minus 6 whole power 1 by 2, 1 by 4 minus 6. In the next step 3x minus 16 by 4 into 4 minus 6, 1 by 2 plus 1. We add the powers 1 by 2 plus 1. So in the next step 3x minus 16 by 4 into 4 minus 6. Next just multiply 1 by 2 plus 1. That means 2 plus 1 3, 3 by 2. So we write it in the next step. So this is the f double dash of x. Now we substitute the x equal to 8 by 3. So f double dash of 8 by 3 equal to 3 into 8 by 3 minus 16 by 4 into 4 minus 8 by 3 into whole power 3 by 2. So f double dash of 8 by 3 equal to, that means 8 minus 16 by 4 into 12 minus 8 by 3 whole power 3 by 2. So minus 8 by 4 into, just you subtract this, 12 minus 8 is 4 by 3 whole power 3 by 2. So it is a minus value. So minus sign in the answer. So it is a less than 0. Less than 0 means it is a maximum. So maximum means the curve has local maximum at x equal to 8 by 3. So substitute x equal to 8 by 3 in the y point. Y equal to x into square root of x minus 4. So y equal to x value is 8 by 3 into square root of 8 by 3 minus 4. So just doing the cross multiplications. So 8 minus 12 by 3. So 8 minus 12 means, that means here x value is, so just doing the cross multiplication 8 by 3 into 8 minus 4 3s are 12. So 12 by 3. So the next step 8 by 3 into, that means 8 minus 12. 8 minus 12 means we write minus 4. So you see our function is y equal to x into square root of 4 minus x, not x minus 4, only 4 minus x. So 4 minus x means we just substitute x into square root of 4 minus x value is 8 by 3. So here 4 minus x. So just 4 minus x means 4 minus 8 by 3. So just doing the cross multiplications. So 12 minus 8 by 3. So 12 minus 8 by 3, here this is the correct. So 8 by 3 into square root of 12 minus 8 by 3, it is a square root of 4 by 3. Again you take the square root for 4. Square root of 4 is 2. 2 by square root of 3. So 8 by 3 into 2 by square root 3. Therefore 8 is a 16. 16 by 3 into root 3. This is the y point. Therefore x equal to 8 by 3 x equal to 8 by 3 and y equal to 16 by 3 into root 3. Therefore the local maximum value is 16 by 3 into root 3. So this is the local maximum value. Next, intervals of concavity. So now f double dash of x equal to 0. F double dash of x equal to 0 means, that means f double dash of x is, that means 3x minus 16 by 4 into 4 minus x whole power 3 by 2 equal to 0. So the denominator term is 0. So the numerator term 3x minus 16 equal to 0. So 3x equal to 16, x equal to 16 by 3. Therefore x equal to 16 by 3 not belongs to minus infinity comma minus 4. Therefore minus infinity comma 4 on f double dash. That means this is not belongs to minus infinity comma minus 4. Therefore minus infinity comma 4 on f double dash of 0 equal to, I substitute the x equal to 0 in the f double dash. So x equal to 0 means I substitute in the f double dash means 3 into 0 minus 16 by 4 into 4 minus 0 whole power 3 by 2. I write it here 3 into 0 minus 16 by 4 into 4 minus 0 whole power 3 by 2 equal to 0 minus 16 by 4 into 4 into 4 power 3 by 2, that means 2 square into 2 square power 3 by 2. So 3 3 2 2 cancelled, 2 power 3. So this is you see, or otherwise you keep as it is, that means 4 into 4 power 3 by 2. You see there is a minus sign in the answer. So minus means it is a less than 0. Less than 0 means it is a concave downward. So there is no point of inflections here, no point in the inflection. So this is the, that means so this is a critical point, that means 8 by 3 comma 16 by 3 into root 3. This is a critical point. So the asymptotes, the curve does not have any asymptotes. This is the answer for asymptotes. Now is discuss about the third problem, that means y equal to x square plus 1 by x square minus 4. So the domain, first we calculate the domain. So domain is, first we take the denominator term equal to 0. X square minus 4 equal to 0 means x square equal to 4. So x equal to plus or minus 2. X equal to plus or minus 2 means x equal to minus 2 and x equal to plus 2. So therefore the domain of the function or in the entire interval is minus 2 comma plus 2. Therefore real except minus 2 comma plus 2. Next intercept, x intercept means you take y equal to 0. So y equal to 0 means here you substitute 0 equal to x square plus 1 by x square minus 4 equal to 0. So x square plus 1 equal to 0 means x square equal to minus 1. So x equal to square root of minus 1 means x equal to I. It is imaginary. The curve does not intersect x-axis. So the curve does not intersect the x-axis means it is a, because from the x1 has the imaginary values. So from this I conclude that the curve does not intersect x-axis. Next y-intercept. Y-intercept means we take x equal to 0. That means y equal to 0 square plus 1 by 0 square minus 4. So minus 1 by 4. Y equal to minus 1 by 4. This is the value, x equal to 0 and y equal to minus 1 by 4. So now we find out the critical points of the function. Critical point means we find out the critical point. The condition is f dash of x equal to 0. So first I consider the given function y equal to x square plus 1 by x square minus 4. I take f of x. So because y means it is a y equal to f of x, I substitute f of x equal to x square plus 1 by x square minus 4. So the next step, f dash of x. F dash of x means now, that means now it is there is a u by v method. So d of u by v, d of u by v is, that means differentiation of u by v means first we square the denominator. So v square into v into du minus u into dv. This is the formula of d of u by v. So now I differentiate the x square plus 1 by x square minus 4. So first square the denominator, x square minus 4 whole square. The next step, x square minus 4 into differentiate the numerator, x square plus 1 whole dash. So differentiation of x square plus 1 is 2x minus next x square plus 1 into differentiation of denominator. Differentiation of denominator is x square minus 4. So 2x. So in the next step I write it, that means I multiply the 2x in the factor, 2x into x square, 2x cube minus 8x. Next minus, so 2x into x square, 2x cube into 1 into 2x, 2x. Next that means we multiply the minus 2x in the factor. So minus 2x square minus 2x. So in the next step here 2x cube minus 8x minus 2x cube minus 2x. So plus 2x cube minus 2x cube cancelled. So minus 8x minus 2x minus 10x. So f dash of x equal to minus 10x by x square minus 4 whole square. So in the next step now we take the critical point. Critical point condition is f dash of x equal to 0. F dash of x equal to 0 means minus 10x by x square minus 4 whole square equal to 0. Minus 10x equal to 0 means x equal to 0. So I represent x equal to 0 in the number line, that means minus infinity comma plus infinity, x equal to 0. So hence the critical numbers of the curve is x equal to 0. So this is the critical point. The critical point is x equal to 0 is the critical point. Now we find out the local extrema. Local extrema means we need the f double dash. So I take the f, already we found the f dash of x. F dash of x equal to minus 10x by x square minus 4 whole square. From this we will find out the f double dash. So I write this equation here. f dash of x equal to minus 10x by x square minus 4 whole square. Now again second time I differentiate with respect to x. So f double dash of x equal to, now that means we squaring this, so we square the denominator, x square minus 4 whole square, so whole power 4. I write the denominator x square minus 4 whole square into, I differentiate the minus 10x. Differentiation of minus 10x is minus 10, because differentiation of x is 1, so minus 10 in the middle minus. Next now I write the numerator term, numerator factor minus 10x into, now I differentiate the denominator. Differentiation of denominator, x square minus 4 whole square, 2 into x square minus 4 into differentiation of x square is 2x. So f double dash of x equal to minus 10 into x square minus 4 whole square plus 40 x square into x square minus 4 by x square minus 4 whole power 4, which implies f double dash of x equal to, that means we take the common factor. Common factor is x square minus 4 is a common factor, so we take from these two terms. So x square minus 4 into, we write it, the remaining factor is minus 10 into x square minus 4 plus 40 x square. So x square minus 4 into minus 10 into x square minus 4 plus 40 x square. This is a common factor. This bracket will come here, the last. So next step, x square minus 4 cancelled. So remaining, the denominator comes to x square minus 4 whole cube, because one factor is cancelled. So x square minus 4 whole cube into the numerator is minus 10. Now we multiply the minus 10 in the factor. So minus 10 into x square minus 10 x square minus into minus plus 40. Next plus 40 x square by x square minus 4 whole cube. In the next step, this is f double dash of x. So f double dash of x equal to, now just add it, minus 10 x square plus 40 x square. We got the answer 30 x square plus 40 by x square minus 4 whole cube. So in the next step, we write it. You see the f double dash sign. So now I substitute, this is a critical point. Now I substitute the critical point value x equal to 0 in the f double dash. So f double dash of 0 equal to, this is a 0, this is a 0, 40 by 0 minus 4. 0 minus 4 means minus 4 whole cube is minus. So minus the answer. Therefore minus in the answer means we represented the less than 0. Less than 0 means it is a maximum. The curve has local maximum at x equal to 0. Now we find out the local maximum value. So I substitute x equal to 0 in the given function. We know that the given function is y equal to x square plus 1 by x square minus 4. So I substitute x equal to 0. So 1 by minus 4, minus 1 by 4, y equal to minus 1 by 4. Therefore the local maximum value is y equal to minus 1 by 4. Intervals of concavity. Now we find out the intervals of concavity. So you see, let f double dash of x equal to 0. So this f double dash second derivative equal to 0 means 30 x square plus 40 equal to 0 means I write it 30 x square equal to minus 40. So x square equal to minus 40 by 30. So x equal to, that means 0 0 cancelled. So x square equal to minus 4 by 3. It is the imaginary answer, because x equal to square root of minus 4 by 3. Square root of minus 4 by 3 means, that means I into square root of minus 1 is the I into 2 by root 3. It is the imaginary answer. There is no point of inflection. Therefore assumed, next we find out the asymptotes. So I write it, the given function y equal to x square plus 1 by x square minus 4. So now this denominator means x square minus 4 equal to 0 means x square equal to 4, x equal to plus or minus 2. So I take the limit x tends to plus 2 and x tends to minus 2. So first I consider x tends to minus 2. Minus 2 minus, it is a left limit, it represents the left limit. So limit x tends to minus 2 minus into f of x. So equal to limit x tends to minus 2. I write the given function x square plus 1 by x square minus 4. So the next step, now I substitute x equal to minus 2. Minus 2 whole square plus 1 by minus 2 whole square minus 4. So minus 2 whole square plus 1 by minus 2 whole square is 4. 4 minus 4, 0. So 1 by 0 is infinity. So the left limit of the infinity is minus infinity. So here we write it the infinity. Next limit extends to -2 plus. -2 plus means it represents the right limit. So y equal to, that means limit extends to -2 plus, I write the given function x square plus 1 by x square minus 4 equal to x value is -2. I substitute -2 whole square plus 1 by -2 whole square minus 4. So equal to, that means -2 whole square is 4, 4 plus 1 5, here 4 minus 4 0. So the numerator is 5, denominator is 0. So 1 by 0 is infinity. So here infinity means here, that means the right limit of right limit of infinity is plus infinity. Here plus infinity come, here minus infinity will come, because it is a left limit. Left limit of infinity is minus infinity. Plus means right limit. Right limit of infinity is minus plus infinity. Here plus infinity, here minus infinity. So this answer is, that means the vertical asymptote, that means the answer will come plus or minus infinity. So we represented both the infinity, we represent plus or minus infinity, plus or minus infinity. So answer are same, therefore it represents the curve passes through the vertical asymptote. This is the number line. I represent the, that means x equal to -2. -2 means left limit, and x equal to that, here -2 plus means it represent the left limit. Left limit means it is a positive numbers. It will go, it towards on positive numbers. Minus infinity means it is towards on, it goes to negative numbers. So you see, limit extends to 2 minus means left limit. Y equal to limit extends to, that means just before we substitute the -2. So now we calculate the +2. So now we calculate the, that means +2 left limit and plus 2 right limit. So 2 minus means it is the, it depend on, it represent the left limit. Left limits means it is the negative numbers. This is the left limit, this is the right limit. 2 plus means it is the right limit. Positive numbers, it take the positive numbers, it take the negative numbers. So here, so limit extends to 2 minus y equal to limit extends to 2, that means I write the 2, and next I write the given function x square plus 1 by x square minus 4. This is the given functions. Now I substitute x equal to +2. Here +2 will come, not -2. So that means I write it, that means I write it you see, limit extends to 2 minus means left limit. I write it limit extends to -2 minus. So x square plus 1 by x square minus 4. I substitute x equal to -2. So -2 whole square plus 1 by -2 whole square minus 4. So -2 whole square plus 1 by 4 minus 4 0. So -2 whole square is, so 1 by 0 is infinity. The left limit of infinity is minus infinity. Next I find the right limit. Limit extends to 2 plus y equal to limit extends to -2 plus x square plus 1 by x square minus 4 equal to, I substitute, that means x equal to -2 whole square plus 1 by -2 whole square minus 4. So you write it, -2 whole square is -2 whole square plus 1 by 4 minus 4 0. So therefore 4 minus 4 0 means 1 by 0. 1 by 0 means infinity. So the right limit of, so in infinity we write it, that means it is a plus infinity will come, because the right limit of infinity is plus infinity. Therefore any vertical asymptote we represent the plus or minus infinity, plus or minus infinity. Therefore both answers same. The curve passes through vertical asymptotes, x equal to -2 and x equal to 2. Again now I apply the horizontal asymptote. Horizontal asymptote condition is limit extends to plus infinity f of x equal to L, limit extends to minus infinity f of x equal to L. So now that means I write the given functions. This is a given function. So x square plus 1 by x square minus 4 by x square. The next step, now I divide this x square in the each numerator term. So x square by x square plus 1 by x square by x square by x square minus 4 by x square. And the next step, y equal to 1 plus 1 by x square by 1 minus 4 by x square. So limit extends to infinity minus. Infinity minus means it is a left limit. So into y, limit extends to infinity minus I substitute the function 1 plus, here this is the function 1 plus 1 by x square by 1 minus 4 by x square. So I substitute x equal to infinity. So 1 plus 1 by infinity, 1 minus 4 by infinity. So 1 by infinity is 0. 1 minus 0, so 1. This is our limit. That means the left limit is 1. Left limit answer is 1. Y equal to 1. Next we calculate the limit extends to infinity plus means right limit. Now we calculate the right limit for infinity. So into y, limit extends to infinity. Now I write the function 1 plus 1 by x square by 1 minus 4 by x square. So I substitute x equal to infinity. 1 plus 1 by infinity by 1 minus 4 by infinity. I just 1 by infinity is 0. So 1 plus 0 by 1 minus 0. So here 1. So 1 by 1, 1. Therefore y equal to 1. The curve has the horizontal asymptotes at y equal to 1. So therefore this is a vertical asymptotes. The curve passes through the asymptotes. That means this is a vertical asymptote. X equal to minus 2, x equal to 2 is the vertical asymptote. Y equal to 1 is the horizontal asymptote. Now we discuss about the fourth problem. Y equal to 1 by 1 plus e power minus x. Y equal to 1 by 1 plus 1 by e power x equal to, that means just doing the cross multiplications. 1 by e power x plus 1 by e power x. In the next step I write the e power x in the numerator. So e power x by e power x plus 1. In the next step I write it e power x by e power plus 1. This is the y given function f of x equal to e power x by e power x plus 1. Now I calculate the domain. So the domain is minus infinity to plus infinity. Intercept, next I calculate the interceptor. X intercept means y equal to 0. I substitute here. That means e power x by e power x plus 1 equal to 0. E power x equal to 0. So e power x equal to 0 means x equal to, that means e power x equal to 0 means x equal to minus infinity. This is the answer. So no x intercept. Intercept is x equal to 0. So y equal to e power 0 by e power 0 plus 1, 1. That means 1 by 1 plus 1, 1 by 2. Critical, now y equal to 1 by 2. Critical point of the function is f of x equal to e power x by e power x plus 1. So f dash of x equal to, that means now I apply the differentiation of u by v. So e power x plus 1 whole square into e power x plus 1. Differentiation of e power x is e power x minus e power x into differentiation of denominator. Denominator differentiation is e power x, because differentiation of e power x is e power x. Differentiation of 1 is 0. So I write it. Now I multiply the factor e power x plus 1 into e power x minus e power x into e power x by e power x plus 1 whole square. So which implies f dash of x equal to, I take the common factor from this. So e power x is the common factor. E power x into e power x plus 1 minus e power x plus e power x minus e power x cancelled. So I write it 1 by e power x plus 1 whole square. Therefore f dash of x equal to e power x by e power x plus 1 whole square. Now find out the intervals of concavity. Intervals of concavity means we need the f double dash of x equal, and the condition is f double dash of x equal to 0. So already we found the f dash of x. F dash of x equal to e power x by e power x plus 1 whole square. So this is a u by v. So here u by v means so differentiation of u by v is, that means v square into v into du minus u into dv. So again, so I write the numerator by denominator. So here now I square the denominator, e power x plus 1 whole square, so whole power 4. Next I write the denominator e power x plus 1 whole square. I differentiate the e power x. Differentiation of e power x is e power x minus, next I write the numerator e power x and into, next differentiation of denominator. Differentiation of denominator is 2 into e power x plus 1 into differentiation of, and next first I differentiate the power, 2 into e power x plus 1 into 2 minus 1 is power 1. Next I differentiate the base. The base is e power x plus 1. Differentiation of e power x is e power x plus differentiation of 1 is 0. So e power x. So the next step, f double dash of x equal to, now you see, e power x plus 1 whole square into e power x minus 2 into e power 2x. E power x into e power x, it is a e power 2x. So 2 into e power 2x, e power x plus 1. Now you see, you take the common factor. The common factor is here e power x into e power x plus 1. This is a common factor. So e power x into e power plus 1. This is a common factor. So write it, e power plus 1 minus, so the remaining factor is e power x plus 1 minus, that means 2 into e power x, because the first term I take the e power x and e power x plus 1. So remaining term is e power plus 1, e power x plus 1. So minus, again in the second term I take the e power x and e power x plus 1. So remaining term is 2 e power x. Therefore e power x into e power x plus 1 into e power x plus 1 minus 2 e power x by e power x plus 1 whole power 4. So in the next, now we cancel the numerator and denominator. So e power x plus 1, e power x plus 1 we cancelled. So the remaining terms are e power x into, now e power x plus 1 minus 2 e power x by e power x plus 1 whole cube. So the next step, f double dash of x equal to, now we write it. We write, that means here e power x plus 1 minus 2 e power x. This can be, we write 1 minus e power x. So here e power x plus 1 minus 2 e power x, we write it 1 minus e power x whole cube. So 1 minus, here e power x 1 minus e power x whole cube will come, not whole cube, whole square. So the formula is a square minus 2ab plus b square. So here just we add it, e power x minus 2 e power x, we add it, we get the answer minus e power x. So 1 minus e power x by e power x plus 1 whole cube. So e power x into 1 minus e power x by e power x plus 1 whole cube. So the next step we write it, e power x into 1 minus e power x by e power x plus 1 whole cube equal to, that means f double dash of, now we find out the intervals of concavity. So f double dash of x equal to 0. So e power x into 1 minus e power x by e power x plus 1 whole cube equal to 0. So e power x into 1 minus e power x equal to 0. The numerator equal to 0. So the numerator equal to 0 means here there is a 2 factor. One is e power x, another factor is 1 minus e power x. So e power x equal to 0 and 1 minus e power x equal to 0. 1 minus e power x equal to 0 means e power x equal to 1. So e power x equal to 0, another value is e power x equal to 1. So therefore x equal to minus infinity. So x equal to minus infinity means, now that means e power minus x, e power x equal to, here that means e power minus x equal to 0. So I taking the log. So e power minus x equal to 0 means I write it, e power x equal to 0 means, so I take the log. So x equal to log 0. Log 0 is minus infinity. So x equal to minus infinity. Another factor, that means 1 minus e power x, the equal to 0, that minus 1 right in the right hand side. So minus e power x equal to minus 1, minus cancelled, e power x equal to 1. That means this 1 I write it e power 0, x equal to 0. Therefore the value is x equal to 0, I represented the number line, minus infinity, 0, infinity. Therefore intervals are, that means minus infinity comma 0, 0 comma infinity. Therefore f double dash of x equal to, you write it, f double dash of x equal to e power x 1 minus e power x by e power x plus 1 whole cube. Now I substitute x equal to 0 here. So the first I consider the, that means I consider the interval minus infinity comma 0, minus infinity comma 0. So any value you take from this interval. So suppose you take x equal to minus 1, you substitute here, e power minus 1, 1 minus e power minus 1 by e power minus 1 plus 1. So next, so the answer comes to positive. So therefore it is a concave upward. Next 0 comma infinity means you take x equal to 1. So x equal to 1 means e power 1. So 1 minus e power 1 and e power 1 plus 1. So the answer comes to the minus. So minus means less than 0, concave downward. Therefore the point of inflection or at x equal to, the point of inflection or at x equal to 0. So x equal to 0 means you just substitute x equal to 0 in y equal to e power x by e power x plus 1. Therefore y equal to e power 0 by e power 0 plus 1 means 1 by 1 plus 1. That means y equal to 1 by 2. The point of inflection is x equal to 0 and y equal to 1 by 2. This is the point for the inflections. You see, that means asymptote. Asymptote means y equal to 1 by 1 plus e power minus x. You take the limit. So limit x tends to minus infinity, y equal to limit x tends to minus infinity. So 1 by 1 plus, you substitute x tends to minus infinity, minus into minus plus infinity, e power infinity. E power infinity is infinity. So 1 by infinity 0. So y equal to 0. Next limit x tends to infinity. Limit x tends to infinity means into y. So limit x tends to infinity 1 by 1 plus e power minus infinity. So e power minus infinity means 1 by 1 plus 0. It is a y equal to 1. The horizontal asymptotes are y equal to 0 and y equal to 1. This is the horizontal asymptotes. This is the asymptotes curve. So this is the asymptotes curve. We complete the class.